Good morning, everybody. Welcome to Turfgrass Epistemology. I'm TravisShaddox. So happy you could join me today. If you're here at this channel, you're looking for information about how we know what we know about turfgrass science. It is March 25th, 2024, and I am here in Lexington, Kentucky. Good morning to Andrew Burris, Keith Madison, Internet Surfer, Super TA, Gray Fox, Turf Nerd Lawn Care, and Transition Zone Guy. We're going to have a fun day today. I had a good weekend. I hope everybody else did. And had about, 15 or 20 Brazilians over at my house yesterday, having a little Sunday afternoon barbecue. One of the Brazilians had a 1-year-old birthday. So we celebrated her first birthday, or I guess second birthday, technically. Had a good time. Beautiful day here. Finally had a good day or two in Lexington. I think this week's going to be nice too. Hope everybody else is doing well. I'm going to start the multi-year soil testing study today. It looks like it might rain a little bit tomorrow. I don't have any irrigation, so it might rain a little bit tomorrow, it looks like. So today would be a good day to get out the study. So if you want to know more about that study, you'll need to be a member of the channel. I'll be posting various, information about that study. I can't post all the details about the study, even for the members, because there's a certain amount of anonymity I need to maintain with the treatments. But I'll have some photos and some basic information. And then the gist of it is, what soil testing philosophy is the most efficient when interpreting a test or applying nutrients or whatever the case might be. So I have 4 or 5 different treatments, and it's going to be a multi-year study, probably more than 2. And I can just only give you bits and pieces until I get everything completed. There's a certain amount of information that needs to remain confidential in order to publish it. In other words, you can't publish data that's already been published somewhere else. So you got to be a little careful with how you share that information before it gets published. But anyway, this is the last week of open public lectures or episodes in the morning. So if you enjoy these morning shows, it will be members only starting in April. So consider doing that. And it's basically $1 an episode. It's not much considering I think what you receive for it. And if that doesn't tickle your fancy, the money goes to support the turfgrass research. So in both ways, you may benefit. Joshua Minturn, I think is what it says. Joshua Minturn just became a pro member. Thank you, Joshua. As I've mentioned before, the proceeds go to support the channel and keep it on air, which is good. It goes to support the various software like Zoom and all the stuff that I need in order to provide the value to you guys. And any remaining revenue after the expenses are paid goes into turfgrass research. My turfgrass research. And I'll share all those expenses and show you all the money if you guys want to see it. No problem. There's nothing to hide here. So that's what I'm hoping that the channel kind of turns into, is a little bit of support for that area of my interest. So, for anybody that's new, the channel is live Monday, Tuesday, Wednesday morning right now, and then Thursday night this week, and then in April it'll start being just Monday morning at 10 a.m. for members, and then Thursday evenings will be open to the public. The episodes go on the podcast, all your podcast platforms, the following day as soon as YouTube gets through doing their processing of the video, which for some reason takes 24 hours. I have no idea why it takes so long. Or no, it takes 12 hours, 12 to 13 hours. I don't know why it takes so long to process the video, but it does. Okay, so today I'm going to go over a article that I went over. I think it was the second or third article I ever went over, when I think there was one person watching. In fact, I think if you can go back, you can go back and actually watch an episode that I did on this article. And you can see in the chat, I think there's one person. I think it was Aldo or Super T. I can't remember who it was. But it was literally one person there. And I think I gave half the episode to no one. There was 0 people watching, and then someone popped in at the like halfway through or something. So where I'm going with that is that when I initially went over this article, the channel was in its infancy. Well, it's still in its infancy, but there was no one watching. I think I had 4 subscribers. That's all I had. And so this paper is important. It's on potassium. It's on warm season grass. And I want to go over it again here with a little bit more detail than I did in the past. So that's what we're going to do. We're going to get right into it. So the title of this paper is nitrogen. Let's see if I can get that up. Nitrogen potassium fertilizer ratios for Bermudagrass turf. For some reason, I've been getting a lot of people interested in wanting me to go over warm season grasses. Just so everybody's on the up and up, I'm a warm season turfgrass researcher. I've been in Kentucky only for about maybe 5 or 6 years. So I have limited, my expertise is limited on cool season fertility, right? My expertise is really on warm season grasses, Bermudagrass, St. Augustine grass, Bahia grass, centipede grass, in terms of nutrition anyway. And so I'm happy to go over the warm season grass literature. Just there's so much literature on cool season grasses, and the literature on warm season grasses is fairly limited just because the market is so big for cool season grasses. I guess there's a lot more work done on it. This paper was published by Dr. Snyder and Cesar, who were at the facility where I was an assistant professor in Fort Lauderdale for a few years. And Dr. Cesar was there for 20, 30 years. Before me, he was there for 20, 30 straight years. And Dr. Snyder is, both these guys are rock stars. Dr. Snyder is, I don't know how you'd find someone more knowledgeable in turfgrass soil science than Dr. George Snyder. It'd be hard to find, but these two guys teamed up for most of the 80s and 90s. Well, actually, the 80s and most of the 90s, most of the 2000s, and put out a lot of students and a lot of papers. And this is one of the many good papers they put out. This was published in Crop Science in 2000. So please consider going to crops.org. You can just copy and paste the title of this article in Google. It'll pop right up. And you can read the abstract for free. And pretty much the abstract is well written, and you can see more or less what they did in the results pretty clearly. Dr. Snyder is very good at what he does. So let's get into it. I'm going to show most of the results in PowerPoint. But this is a very easy article to understand, very straightforward. And I think even, an entry-level beginner scientist or grad student or a homeowner, anybody, I think most people can kind of make their way through this article and get some key points out of it. So that's what we're going to do. Turfgrass fertilizers generally contain more nitrogen and potassium than other nutrients, since nitrogen and potassium are required by turfgrass in greater amounts on a mass basis than those of other fertilizer elements. Notice he says fertilizer elements, so he's not talking about carbon, hydrogen, and oxygen. Because turfgrasses have been shown to take up approximately half as much potassium as nitrogen, it is sometimes recommended that these elements be applied in a 2-to-1 N to K ratio. So if you remember in the last episode, I think it was on Thursday night of last week, I was showing a video where the salesman was selling a 702, 7% nitrogen, 0 phosphorus, and 7020, 7% nitrogen, 0 phosphorus, and 20% potassium. And there's other YouTubers who will sell these 1-to-1 N to K ratios and high potassium ratio fertilizers, whatever it is, a 10-0-20 and 5-0-15s and all these high potassium fertilizers. And they'll sell them as stress blends, stress fertilizers. And throughout the channel, at least at this point, you probably heard me say many times, you really don't need to apply that much potassium. It's wasteful. You're wasting money. You're wasting resources by applying so much potassium relative to nitrogen. There's a good reason why I've been saying that. And it's been known for 40 years that when you need to apply potassium, which is extremely rare, you rarely need to apply potassium. You're rarely going to see a turfgrass response to applied potassium. We're going to go over this week 4 papers that clearly show there are times when you need to apply potassium. We're going to go over that. The one on Thursday night was a valued applying potassium for anthracnose on POA. But it's not a normal situation, okay? But if you do need to apply potassium, over and over and over in the literature, the cases where potassium results in a beneficial response, it almost always occurs at the very lowest amount of potassium in that particular study. And they say they do a potassium rate study, which is what this study is. It's a potassium rate study. And the study that Schmidt did on last Thursday night, it had rates of potassium. It was the first rate of potassium, the lowest rate of potassium that resulted in all the benefit. And then they kept applying more and more and more, and there wasn't any benefit to the turf. So when Dr. Snyder starts off and says it's sometimes recommended these elements are applied in 2-to-1 NK ratios, right here by Alturgeon in 85, his book. That's the reason why I say that. You don't need to apply that much potassium because the literature is extremely clear on this issue. Very little. You don't need that much. You don't need hardly any. You don't need any at all to apply any, really, to be honest. But I'm talking about the situations when you have documented the potassium is deficient in the turfgrass. A reduced amount is resulting in some harmful effect. In those cases, you don't need to apply that much. You'll get all the benefit just from a little bit. Okay? So that's the first paragraph. He's saying this is what's recommended. Various studies have focused on the importance of potassium for maintaining turfgrass quality. Improved disease-resistant drought, heat, and wear tolerance. This is Turner and Hummel 92. And enhanced root growth and cold hardiness by Beard in 73. Have been attributed to adequate potassium fertilization. Furthermore, potassium is subject to leaching in many soils or to fixation in other soils. In a growth chamber study, okay, I'm not going to go into all the literature, but potassium has various ways in which it can be released into the soil solution, whereby it's available to be taken up by the plant, or absorbed from the soil solution by the soil. And so the potassium that was soluble and available to be taken up is no longer available because the soil is interacting with that, absorbing it or mineralizing it. And that's what he's saying. Potassium has some benefits. It's in the literature. There are some benefits. And potassium can leach. Potassium can be released. There's all sorts of things that are going on with potassium in the soil. Now I want to go to here. Bruce Augustine in 1992 reported some turf managers are using relatively large amounts of potassium fertilizer. Now, Bruce was at Fort Lauderdale before Dr. Cesar, so we're going way back. And he reported in 1992 the turf managers in South Florida were using a lot of potassium relative to nitrogen. Okay. Fertilizing with potassium in equal amounts or even exceeding the rates of nitrogen, and the authors have observed an increasing trend for turfgrass managers to subscribe to this practice. Now, I have spoken with Dr. Snyder about this particular study, and I worked on those plots that he did this work on. Those plots were still there when I came down there in 2000, whatever it was, 15, 16. I know that location very well. And it's my recollection that Dr. Snyder formulated this concept, this study in his mind, because he was seeing so many managers put out 1 to 10, 1 to 20, 10, 20, 30, all this potassium relative to nitrogen with some sort of delusion that the turfgrass is going to benefit greater from that than from just applying a little bit of potassium. This is was going on and still is going on, let's be frank, in South Florida. There are copious amounts of potassium being applied to turfgrass with some sort of, again, it's a delusion that it's going to result in some additional benefit to the turf compared to just a little bit of potassium. Okay, so he formulated this study in his mind and came up with this really good study. Okay, good morning, Ignacio. For this reason, that they've observed so much potassium being applied. The current study was conducted to evaluate the effect of NK fertilization ratios on Bermudagrass turf growth and visual quality at 3 rates of nitrogen fertilization. So they're going to have nitrogen fertilized at 3 rates, and they're going to have potassium applied at various rates. They're going to look at visual quality and turf growth. They're going to look at a variety of things, okay? The study was established on a mature sward of tiff green Bermuda grass grown on a Hallandale fine sand at the Fort Lauderdale Research and Education Center in Fort Lauderdale. This is in Davie, Florida, for people that know that area. They call it Fort Lauderdale, but technically it's in Davie. It's just across the 595 highway, so it's right there. The field design was a split plot with 6 replications. 6. So on field plots, just so you know, we try to shoot for 3 or 4, ideally 4. In this case, they had enough space and resources. They did 6 replications. So if you think of, like, if you're going out on your lawn or your football field and you say, I just want to put this out and see what happens. I'm going to compare it to, a blank. Okay, you're just going to do that once, more than likely. You're going to do it like, I applied this and I didn't apply it there. Well, you can't really compare anything that way. Statistically, it's impossible to compare anything with one unit. Well, he did that 6 times. The more times you repeat it, the stronger confidence you have, or the greater ability you have to determine differences between treatments. But 4 is typical, and he did 6. The main plot were fertilized with a 0.5 pound, 1 pound, or 2 pounds of nitrogen from ammonium sulfate beginning in February of 1990, and were similarly fertilized near the middle of each month through February 1993. So they're applying a 0.5 pound a month, 1 pound a month, or 2 pounds a month to 328 Bermudagrass. The tiff green Bermudagrass fairways is maintained as a fairway every month. So you do a 0.5 pound a month, that's 6 pounds a year. Now the range for Bermudagrass in South Florida, I think the IFAS recommendation or the limits are 5 to 7. Someone can look that up. I can't remember off the top of my head. Good morning, Kevin Shepard. Thank you for popping in. I think it's 5 to 7 pounds of nitrogen per year. So that's the limit. And they have a 6 pound rate a year, and then they have a 12 pound rate, and then they have a 24 pound rate. They're doing a lot. They're doing these crazy high rates of nitrogen to see if there's any effect. Okay. But one of the rates is within limits, within the BMP limits that we have down there. And it's using ammonium sulfate. And they're fertilized each month in the middle of the month. And then subplots 2 by 3 meters were fertilized with KCl, which is critical, as you all know. We can't definitively know if any response of the turf grass was from potassium if you use potassium sulfate nowadays, because it comes with sulfate, and sulfate has been documented to result in a response. In this case, he used potassium chloride, okay? Which, if there's a response, it's highly likely that it's from the potassium. So on the same day they applied the nitrogen, they split the plot, and it was fertilized with potassium chloride on the same day as nitrogen fertilized to provide K to N ratios so he's going to call it K to N ratios instead of N to K ratios. And the reason for that is if you divide it the other way around, it ends up being an error term. It ends up going to infinity. So he's going to call it 0.51 into potassium to nitrogen. So a 0 potassium would be the equivalent of all nitrogen. So 1 to 0 N to K. A 0.5 potassium would be the equivalent of a 2 to 1 N to K. And then a 1 is a 1 to 1 N to K. And then a 2 in this particular, I'll try to convert this as I'm speaking, but a 2 would be a 1 to 2 N to K. So 1 part's nitrogen, 2 parts potassium. But you have in scientific terms, you have to flip it, because if you don't, it's going to end up being an error. I don't want whatever. I won't bore you to tears on that stuff. But anyway, he applied the nitrogen, and then he cut it with, he split the plots, and he applied various rates of potassium at the same time he applied the nitrogen. Fertilizer ratios are stipulated instead of N to K ratios. The K to N ratios are used instead of N to K ratios, since the no K treatment would produce an undefined N to K ratio, infinity. So no K would be 0, right? So that's the reason he used K to N, which is, again, why I love George Snyder. If you've never had an opportunity to speak with George Snyder, you're missing out. He's extremely humble, but off the chart knowledgeable. Let's just say that. Okay. The area was mowed at 1/2 inch, and the mowing frequency was adjusted to minimize scalping. Clippings were removed. Okay. So we're in Fort Lauderdale on a Hallandale fine sand. They're applying rates of nitrogen. They're splitting that nitrogen plots, and they're applying various rates of potassium. They're mowing it at 1/2 inch, and they're removing clippings. That's going to be critical because when we get to the amount of potassium that existed in the soil when they started, they're not going to continue to drop the clippings on the plots. They're going to remove them. So they're harvesting the potassium off the plots, which is what you'd probably do on a tee or a putting green or something like that. Maybe not a fairway, but that's to keep the potassium low to induce a response if you can see one. Right. 2 weeks after each nitrogen potassium fertilization, plots were rated visually on 1 to 10, with 6 being minimal acceptable. In conjunction with visual ratings, clippings were taken from each plot with a greens mower. Okay. Periodically, soil samples from 0 to 4 inches deep were taken, and were composited across selected treatments, analyzed for pH and Malic 1 potassium. Okay. So this is Malic 1, and they use Malic 1 to extract phosphorus, potassium, calcium, magnesium at the University of Florida Extension Soil Testing Lab. So this is around the time, just after this, they switched to Malic 3. At the time, they were using Malic 1. Now, I know from another study that I actually showed on this channel that the sandy mineral soil, the mineral soils in Florida have been correlated between Malic 1 and Malic 3 potassium with potassium. And the correlation is essentially 1-to-1. There's just a slightly bit more potassium extracted using Malic 3 than Malic 1. So why I'm saying that is Malic 1's not that common anymore. And the Malic 1 was 10 on this study, on this location. So the Malic 3 was probably around 11 or 12. Very low. Okay, and I'm going to show that here in this table in just a second. Thatch depth was recorded. Roots were actually measured as well. And all observations were collected and averaged over the month. So right here in this table here, you're going to see the effect of potassium on soil potassium, the potassium fertilization. I'm just going to show you this column over here in 1993 because they added some treatments between 91 and 93, and they didn't have, make a long story short, I'm just going to show this column, and you can see the other column if you want to see it. But when they applied no potassium at all, the Malic 1 soil K was 10. Okay. So if you're a Malic 3 person, the Malic 3 is around that number. On this, I can say that with confidence because I know I've seen the correlation and I've showed it on this channel. It might be 11, it might be 12, but it's not double. Okay. So let's just say 10. When they added, the potassium rate goes up to, I guess that's a 1/4 pound. Looks like that's a 1/4 pound of potassium. Actually, you know what? I think I'm going to show that actually in a graph anyway. But I just wanted to show this to show that I am going to show that in a graph. The potassium started off at 10, and they're removing the clippings. Okay. The sea level, I have photographs actually on my phone of this. Sea level at this plot, on these plots right here, is about 3 feet above sea level, 3 or 4 feet maybe. Because whenever we have hurricanes and the tide comes in, or the surge comes in, the pond, which is about 50 or 60, well, maybe 50 yards from, not even that, 30 yards from these plots, the pond, which is where the irrigation comes from, goes way up. And then the water, once it gets high enough, it'll actually cover some of the plots on the other side. That's sea level. That's how close this is to sea level. We're literally on beach sand, basically. And the potassium was 10. Now, I'm going to switch here and go to the PowerPoint because, and I just realized let me get over to PowerPoint real quick, and I'm going to skip ahead on a couple slides here because I just realized I messed that up, but that's okay. Okay, now I'm going to, I can't do that. How do I get there? Okay, I'm going to go to PowerPoint, and I'm going to start showing some of the results with PowerPoint. Now, the PowerPoint, the first slide I want to show is this result from, I think it was table 1 or 2, that shows the effect of nitrogen applications on soil pH. And God knows why this even comes up. I don't know how I get involved with this stuff, but every now and then I'm giving a talk and I'm talking about soil pH, or I talk about nitrogen influence in soil pH, and people want to go out and throw sulfur out, or they want to, if they want to reduce soil pH, they want to go out and throw sulfur. I don't recommend that for any amateurs. Okay, I don't recommend, unless you're a pro and you know exactly what you're doing, I don't recommend just going out and throwing out 5 or 10 pounds of sulfur to lower your soil pH. Instead, what I do is I tell them, if you're applying I ask them, are you applying any nitrogen at all? And if they say yes, I'll say what form. Sometimes they don't even know. But I'll say, if you're applying urea or slow release nitrogen or natural organic nitrogen or whatever, just whatever rate you're going at. Say you're going at 1 pound of N per application, or you're doing 3 pounds of N a year, or whatever the case is. I'll say just keep that rate, but switch to ammonium sulfate. Use ammonium sulfate as your nitrogen source. Okay. And over time, it doesn't take that long, but over time, you will lower that soil pH with much less risk than going out with elemental sulfur. Now, if you're a professional and you've done it and you know what you're doing, then that's different. But if you start grabbing elemental sulfur off the shelf at the co-op store, start throwing it out in your lawn or your neighbor's lawn or your customer's lawn, and you don't know what you're doing, that's a real good way to kill some grass. You need to be careful with that. Whereas if you use ammonium sulfate, you might, worst case scenario, you might kind of tip burn it a little bit. If you put it out on dew and you don't water it in, there might be a little bit of tip burn, but the risk of complete death is pretty low compared to elemental sulfur applied incorrectly, okay? So every now and then I'll be talking about that, and someone will raise their hand and say, you can't apply enough ammonium sulfate to reduce the soil pH. And I don't know where that comes from, because it happens all the time. I could pull up 20 articles right now that show soil pH reductions will occur following the regular application of ammonium sulfate to turfgrass. It's not once, but just switch and stay on it for a little while, a year or two, whatever, and you'll see that pH come down. So a reason I'm saying that is because Dr. Snyder showed some data in this publication. And the title of this is Effect of Increasing Nitrogen, so nitrogen applications, on soil pH. And on the x-axis, we're looking at what happened in May of 1990, and then he goes to the next year, January of 91, March of 92, January of 93, and then soil pH is on the y-axis. He also had a very similar data from his manganese paper in 79, I think it was, where he showed the reduction of soil pH following nitrogen applications, ammonium sulfate applications. And in this particular graph, we see in May of 1990, the pH was 6.9 from the half pound nitrogen application, 1 pound nitrogen application, or 2 pound nitrogen application per month. Okay, it was the same. That's when they started, 6.9, 6.8, and 6.9. That's when the pH was, that's what the pH was when they started. And the very next year, January, so it's 10 months later or 9 months later, we see the pH of the half pound per month is 7.2. The 1 pound is 6.9, but now we see the 2 pound dropping down to 6.3. So we see a reduction in pH. March of 1992, the next year, we see a further reduction from all of them now. It's the half, they all started at 6.9. Now, if you applied a half a pound a month of ammonium sulfate, it went to 6.1. Okay, if you apply these high rates, these really, really high rates of 2 pounds a month, you're down to 4.9 in 2 years. Okay, just 2 years, that you would never apply that much nitrogen, and I don't recommend it. This is for research purposes, but it does show the influence of high rates of ammonium sulfate on soil pH. And then in 1993, those pH that started at 6.9, you applied a half pound of nitrogen per month using ammonium sulfate, which is well within the BMPs for that area on that turf grass. The pH went from 6.9 to 5.8. So we dropped an entire 1 point, simply by applying nitrogen within our BMP recommended rates using ammonium sulfate. So I don't know where this comes from that some people think that you can't apply enough ammonium sulfate to reduce soil pH. You're going to reduce soil pH using ammonium sulfate. You're not going to do it immediately, but just regular applications, with as your nitrogen source will very, very likely result in reductions in soil pH. So, I'm not a huge fan of doing anything unless you have a good reason. So I'm not saying you should reduce soil pH. But if you're floating in the 7s and you're convinced somehow for good reasons that is resulting in some sort of harm to your turf or some undesired outcome or undesired appearance, and you want to reduce soil pH, you can use elemental sulfur if you know what you're doing. Otherwise, just switch to ammonium sulfate and just continue about your business. Don't expect miracles that year, but regular applications will result in that. That's what this shows, right? I mean, that's a full unit. And if you keep doing it, this will lower, ammonium sulfate will lower pH down into the 4s easily with regular applications over many years. You don't have to go to these crazy high levels of nitrogen. Again, I don't recommend that. But even the half-pound nitrogen application monthly would very likely continue to decline from 5.8 down into the very low 5s. Okay? That's very consistent in the literature. All right, let's go to the next graph. Now, this is the effect of increasing applied potassium on soil K. Now, this was the table that I just showed a minute ago. On the y-axis, we have Mehlich 1 soil K. On the x-axis, we have potassium applied in 1,000 square feet per year. And it goes from 0 to a quarter to a half to 1, 2, and 4 pounds of potassium. And we see very consistently, not just in this paper, but across many, many papers, you apply more potassium, you're going to get more in the soil. It's just even on this sands. We're applying this every month, and even on the sandy soils that leach potassium. And down there, we're getting in between 60, depending on the year, 60 to 80 inches of rain a year on beach sand. And you apply more and more K, you're going to have more and more K in the soil. Even on sandy soils, even 12 months of growing season, even in high rainfall. There's going to be a limit. At some point, you're going to get the potassium so high that it can no longer hold on to anything, and it's just going to move through, and it's going to be plateaued out. But they didn't hit that limit in this study. Okay. Again, don't be fooled by this sort of stuff if in marketing. They say, well, you apply potassium, the soil potassium is going to go up. Yes, I know. Okay. Soil potassium will go up. I'm not worried about soil potassium going up. I want to know what's going to happen in the turf grass. So this can be used dubiously to fool you into buying something you don't need. Yes, I agree. It will go up in the soil. I don't care. Okay. Don't get fooled. How does it benefit the turf grass? How does that benefit me as a consumer or me as a business person? Just because the soil potassium goes up doesn't necessarily mean it's going to benefit the turf. Okay. So let's go to the next graph. This is the nitrogen potassium ratio on Bermudagrass visual quality. Now, in the previous graph, we saw the potassium. I'll go back to the potassium. When we applied the lowest rate, it went from 10 parts per million here to 40 parts per million. And then when we go to half a pound per month, it went to 80 parts per million. Okay. So we're going up pretty linearly, 10 to 40 to 80, just by applying a little bit. So remember this 40 number. Okay. Here we have the influence of NK ratio on Bermudagrass visual quality. So the blue line, on the x-axis, we have seasons of the year, all 3 years, summer, fall, winter, spring, so forth. On the y-axis, we have turf quality from 1 to 9. I think he went to 10, but he never did get to a 10. The blue line is when you don't apply any potassium. So if you can envision, this line floats right around the minimum level for the first year, and then it drops off below 6 to about 5. It levels off around 5. So after the first year or so, the potassium or the turf grass was not acceptable. Okay. So it floated around minimum acceptable limits, and then it dropped below acceptable limits after the first year when we were just applying nitrogen. Now we apply a 2-to-1. So this would be the equivalent of applying, say, the half a pound of nitrogen per month and a quarter a pound of potassium per month. And we see the quality go up. Okay, it goes up above acceptable limits. It stays around 7 for the the remainder of the year, or the remainder of the study. Pretty much it always stays around 7 the entire 3 years when we applied a half a pound of N per month with a quarter pound of K per month. Okay. Now let's go to apply, instead of applying, a 2-to-1, that's a 2-to-1. Instead of applying 2-to-1, we're going to apply more potassium. Okay. Let's see what happens to the quality when we apply more potassium than a 2-to-1. Now we're going to a 1-to-1 into K. So this is like a 15-0-15. And the quality is identical to the 2-to-1 into K. So we applied a 2-to-1, the quality goes up. We started at 10 parts per million. Now we go up to 40 parts per million, Mehlich 1 extractable potassium. It went up to acceptable limits. Now we apply more potassium. It goes up to 80 parts per million, and the quality doesn't change. Okay? 1-to-1. Now we apply more potassium. We go to a 1-to-2. So it'd be like a 10-0-20 or a 15-0-30, something like that. And the quality doesn't change at all. Again, from a 2-to-1. So what this graph is saying is that with no potassium applied on Bermudagrass in South Florida, on a soil that contained only 10 parts per million Mehlich 1 potassium, when we applied just a quarter pound of K with a half a pound of N per month, we gained back in return for that investment a maximization of the turf quality relative to K. I mean, K provided that the maximum result that you're going to have from potassium occurred at a 2-to-1. We didn't need to apply a 1-to-1, spending more money on potassium. We didn't need to apply a 1-to-2, spending more and more money on potassium. That didn't result in any additional benefit on Bermudagrass visual quality, which is where as you all know, I put a lot of weight in that metric because that's what my clients usually care about. They want to know performance and quality. Okay. So this is the nuts and bolts of the paper. I mean, I'm going to go through a lot more stuff, but we need to make sure that we understand this is that, yes, this paper shows a benefit to applying potassium. It's going to go in the beneficial column in the scoreboard at the end of the show today. But you apply more, nothing happens. So stay with the 2-to-1 on these warm season grasses. And it's not really that much different on cool season grasses. Okay. You might adjust the time of year maybe or something, but the rate that you go out at is not anywhere near a 7-0-20. I mean, it's crazy. You're spending so much money, wasting so much money on all this potassium. When if you have a deficiency, these data show very clearly, just apply a little bit. The quality was maximized relative to K, applying more didn't help. Then we go to N to K ratio on Bermudagrass leaf tissue. See, this is what the leaf tissue, again, we're here with the seasons on the x-axis and K concentration and percentages on the y-axis. And you see a gradual reduction in leaf tissue when no potassium was applied. When you apply a little potassium, the potassium in the tissue goes up. Notice the fluctuations over the seasons. Again, I don't have a lot of confidence in a lot of tissue testing unless we have a lot more information because remember, this orange line was completely acceptable turfgrass. 7 on the quality scale, and it fluctuates from as high as maybe 2.1 to as low as 1.5. And all year long, the turfgrass was acceptable, but the fluctuation goes from a half a percentage. I mean, 1.5 to 2.1. It's a lot of fluctuation there, just based on season. Now we apply a 1-to-1 into K, more K. It's the exact same line basically, maybe just a fraction higher. There's no statistical difference between those two. And apply more K, 1-to-2. A fraction a little bit higher. Again, there's no statistical difference on these lines. Okay. So the leaf tissue might have a slight bump increase, maybe in potassium, but that doesn't result in any additional quality benefit. The benefit came from when no potassium was applied to applying just a little bit. Okay, that's when the benefit kicked in, and there really wasn't any need to apply more and more K. Now let's go to the effect of N to K on Bermudagrass leaf nitrogen. Sometimes it's not normal. Occasionally I run into this question. Well, I'm applying potassium because it alleviates stress, and you're going to have more nitrogen taken up in the leaf because it was deficient in K, and so I don't know where I get that from. It's not very common, but I do get that occasionally. But there's no evidence to support that, and this is what this shows. We see all the quarters of the year that he did the study on the x-axis and nitrogen content percentage on the y-axis. And the potassium, or the nitrogen percentage in the leaf tissue, was exactly identical from whether you applied no potassium or whether you applied all extra potassium or any potassium at all. The leaf tissue nitrogen was not affected by the application of potassium. So don't believe that if that's what, I mean, it's not particularly common, but occasionally I'll get that. Leaf tissue nitrogen in this study was completely unaffected by the application of potassium. Okay, now let's go back to the PDF here. And I'll wrap this thing up. Okay, I'm not going to read all through that because I want to read one thing, actually. There was one additional benefit that kind of peeked out, kind of came out a little bit. I want to make sure I cover that. I didn't even highlight the paragraph, but I'm going to read most of it. Okay, so for the most part, before we go further, that's the results. Okay. When no potassium was applied on low-K soils, the application of potassium resulted in an increase in quality. The further addition of potassium didn't help any, whether it was in the quality or whether it was in the leaf tissue. Potassium. The application of potassium didn't help anything in the nitrogen in the tissue at all. The leaf tissue nitrogen was the same regardless of whether you apply potassium or not. There was an additional benefit that you got to drill down a little bit in this paper in order to see the potential value in this setting to applying potassium. Occasionally stuff like this will happen where you'll be conducting a study. Well, the same thing happened in Dr. Woods' study. He was conducting a study with a defined objective, but during the study, something else happened that he didn't expect, and so you start taking data on that. And that's happened in one of my studies as well, where we had disease outbreak during a study, or I had a tropical storm during the study. And you don't want to stop taking data because something weird happens. Go ahead and keep collecting data, because how many times are you going to have a turfgrass study going on when the tropical storm hits? I mean, how many times are you going to be able to measure the impact on that? So you go ahead and do it. And in this study, what they were doing, they were collecting quality ratings and tissue ratings. And in the middle of the study, they ended up having a Bermudagrass decline occur. And it happened at the highest nitrogen rates only in one quarter. But I want to read this and show you the data in that one quarter, because it may provide a little bit of additional strength to the potassium argument. Okay. Nitrogen fertilization always had a significant influence on visual quality ratings in all quarters except one. Nitrogen increased visual rating scores. Okay. However, in the third quarter of 1991, there was a significant decrease in visual quality. With increased nitrogen, a severe outbreak of Bermudagrass decline disease, also known as take-all, caused by Gamenomyces graminis, was observed during this quarter, and this was confirmed by one of the better turfgrass pathologists of our age, Dr. Monica Elliott, who was also one of Dr. Cesar's and Snyder's colleagues in Fort Lauderdale. So she happened to be on site, and she was at the time a turfgrass pathologist. I think she moved more into palms later in her career, but at the time in 91, she was a turf pathologist and very good at what she does, and she diagnosed the plots as Bermudagrass decline. Ratings for disease severity on 18 September 1991 revealed that the disease was aggravated by high nitrogen, confirmed by Dr. Elliott. When rated on a scale of 1 to 5, where 5 indicated no disease and 1 indicated 80 to 100% disease, thinning of chlorosis of turf due to disease, the half pound, 1 pound, and 2 pound nitrogen rates produced ratings of 4.7, 2.8, and 2.3 respectively. So in other words, there was a lot of disease relative to the amount of nitrogen you put out. Outbreak of this late summer disease was not observed in the first or last year of the study. However, plots ratings at higher nitrogen rates were somewhat lower after quarter 1991 than they were the period before. Okay, so what I want to say is on this paragraph is during one quarter there was a disease outbreak that was exacerbated by nitrogen applications, and I want to show that in this graph or in this table right over here. It says the effects of effective nitrogen and potassium nitrogen fertilization ratios on visual quality, which is which was included in the previous graph. This actual data was actually in the previous graph. But I'm just going to highlight just 1/4 of all those line graphs. And in here, they're talking about this quarter number 3 right here in 1991, where nitrogen applied at half, 1, and 2 pounds of nitrogen per month went from 6.3 to 6 to 5.7. So more and more nitrogen, the quality went down. Okay, no problem. They confirmed that with Dr. Elliott. The increased rates of nitrogen resulted in increased Bermudagrass decline during that particular 1/4 and didn't happen any other time. No problem. But let's look and see what happened when potassium was applied during that same quarter. When no potassium was applied during that same quarter, the quality was 4.9, shown here. Okay, so very unacceptable. I mean, that you'll know that relative to an acceptable plot. I mean, it's a 4.9 out of 10. I guess they rated it 1 to 10. Acceptable is 6. But look, when we apply a half the amount of nitrogen, we applied potassium. So the half pound nitrogen came with a 1/4 pound of K. The Bermudagrass decline it wasn't 4.9. It only declined to 6.2 when a little bit of potassium was applied. It went down to, the quality was 6.4 and 6.4 and more potassium was applied. So in other words, when no potassium was applied, the Bermudagrass decline was exacerbated. It was the greatest when no potassium was applied. And when a tiny bit of potassium was applied, we saw a benefit, meaning the quality reduction was not as great. Okay. There was a benefit in this particular quarter by reducing the magnitude of decline of Bermudagrass decline. Okay, and that's shown right here in this particular significant level here. Okay. So it was 0.01 or 0.0. What was that? How do they have that denoted? 0.01. Yeah, so it was 0.01 significant. So it was highly significant. So out of all these quarters, you only saw a benefit to applying this excess potassium. You saw a benefit to applying some potassium. But in this particular case, you saw a benefit to applying some potassium during the incidence of Bermudagrass decline. So I wanted to make sure that was clear. There was a little bit of benefit there. Okay, so now I want to go to this table right here on clipping weights, and we show that there was an influence of the end-decay ratio on clipping weights. But I want to point out that the influence of these elements on clipping weights was primarily from nitrogen. It goes from 1.9 to 22 in the second quarter of 1990 when you apply more and more nitrogen. When you apply more and more potassium, you do see a slight benefit when you apply potassium. It goes from like 10 to 12 or 10 to 11 on grams per meter squared. So, in other words, there are occasions where there might be a small benefit to applying potassium, but it was primarily when potassium was compared to no potassium. In other words, applying more and more potassium did not result in a concomitant increase. It was just applying a little bit of potassium. That's where the difference occurred. But even that increase that was observed or measured, that was nowhere near the magnitude measured when nitrogen was applied. Okay, so let's keep things in perspective is what I'm saying. Can you increase, does this paper show there was an increase in clipping weights resulting from the application of potassium? Yes, there are occasions where that did occur. But the major impact was from nitrogen, and the impact from potassium was just small, and it was only from when no potassium was applied to a little bit. The differences between applying a little bit of potassium and a lot of potassium never occurred. There was no additional real benefit from applying more and more potassium, even on clipping weights. Okay, and you can see all those data here in Table 4. Okay, now let's go to I already showed that, I think, potassium in the clippings. Okay, now let's go to the thatch and the roots. Whenever we, a lot of people for some reason are convinced that potassium is going to influence roots. Potassium almost never influences roots. okay, primarily because most turfgrass is growing in potassium sufficient soils, okay? That's usually not deficient in potassium. But even in situations where the turfgrass is growing in soils that are low in K, which is this soil, okay, it started off at 10 parts per million Mehlich 1. Even then, the application of potassium rarely results in a root influence. Okay, I'm going to show you that. Here we see the influence on the K to N ratios. We're going, as this goes down, we're going up and up in more potassium. Okay, so we're going from 0 potassium applied to a 2 to 1, a 1 to 1, and a 1 to 2 N to K ratio. Okay, and all of 1990, there was no influence. That increasing potassium had no influence on thatch or in roots in the top layer or the bottom layer or in total roots. There was no influence of the potassium had no influence on thatch or on roots all of the year of 1991. Okay, in 1993, there was a increase in roots following the application of potassium. So in one of the 3 years, there was an increase in root mass resulting from the application of potassium. In 2 of 3 years, there wasn't. So I don't know how you want to balance that out, but 2 years, nothing happened at all. 1 year, something did happen on low K soils. Also, I want to point out this. Look what happened to nitrogen on roots. I've said this, I don't know how many times. Root work is horrible. It sucks. It's a lot of time. It's so detailed and just slow and boring. You get root scanners, you can do mass, you can weigh it, however you want to do it. It's very, very monotonous and slow. And at the end, you almost never see a result of anything. It's very rare you see anything change the roots. Okay. Even in this study, where we're increasing nitrogen from 0.5 pound to 2 pounds a year, from 6 pounds a year to, what would that be, 24 pounds a year. I mean, it's a lot of nitrogen going out. Maybe I said potassium, sorry. A lot of nitrogen going out. Even in this study where there's so much nitrogen going out, the first year, 1990, we saw a little bit of an increase in thatch. In the top 10 centimeters, top 4 inches, we saw a little bit of increase in roots. Okay, went from 226 to 324 for those listening. So you can see the magnitude of increase, maybe a factor of 1.5 times more roots as you increase the nitrogen. But the entire rest of the study, 1990, total roots, nothing. 1991, total roots, nothing. 1993, total roots, nothing. So even with nitrogen, that's known to have a major impact on plant growth. Even with nitrogen, we don't, in this study, didn't see any significant increase in roots or decrease in roots at all. Nothing happened with the roots relative to nitrogen in the majority of the study, and nothing happened with the roots relative to potassium in the majority of the study. Okay, so that's I get a kick out of these people holding up all these cores on Twitter and YouTube, whatever. Look at all these roots. Well, every time we do these root work studies, well, not every time, but 90% of the time or more, we just don't see differences in root growth. Okay, it just doesn't happen that much. The variation is huge. It's a lot of variation depending on how you measure it and how you collect it, and there's a lot of error involved, and we just don't see many things influence root growth. Of course, you're going to see some, just like I showed here. There's one here at the other end, at the end of the study on potassium. There's one here at the beginning on nitrogen at the beginning of the study. You'll find stuff in the literature occasionally, but I'm talking about the overwhelming amount of information we receive in the literature. It's unlikely you're going to influence roots. So don't have any sort of delusion that I'm going to go out and I'm going to apply potassium and it's going to increase my roots and I'm going to increase my carbohydrates and all these things are going to happen fantastic and below soil. It may, but there's not a lot of evidence to support it, and I don't have a lot of confidence in that occurring. And this is why. Okay, we're now at the end. The ratio of potassium to nitrogen fertilization significantly affected the tissue into K ratio, but most of the effect was between the ratio providing no K and the 3 ratios providing some K. And he says that over and over in this and throughout here. I didn't read the text, but he says that over and over. Let's see where else he says that. Yeah, this potassium to nitrogen ratio significantly affected visual ratings in quality. This effect occurred mainly because the poor performance from plots receiving no K. There were only minor differences in visual gradings among plots that received K, as long as some K was applied. So as long as some potassium was applied, you were fine. The difference between more and more potassium wasn't consistent. There wasn't much difference at all when you applied more and more potassium. However, when potassium was applied in any of the 3 K to N ratio study, there were no differences in root weights among the ratios. So the difference occurred in one part when there was some potassium was applied at the end of the study, but when more and more was applied, there was no differences. A range of soil pH, soil K, clipping height, and disease pressure occurred during the 3 years of the study. Nevertheless, so in other words, there was stress. What he's saying here, a range of soil pHs, range of soil K, clipping heights, and disease pressure occurred. So there were stresses all throughout the study. Nevertheless, even across this range of conditions, increasing potassium fertilization beyond a potassium-nitrogen ratio of 0.5, which is an NK of 2 to 1, had virtually no effect on turfgrass appearance, growth, resistance to Bermudagrass decline, thatch development, or root weight. So that's the conclusions. When they applied no potassium for 3 years, they eventually saw the turfgrass decline. When you applied just a little bit, there was a benefit measured, and you kept applying more and more and more. They didn't see any benefit in terms of turf appearance, turf growth, resistance to Bermudagrass decline, thatch development, or root weight. So all that additional potassium that was applied was waste. Okay, it was complete waste. There was no additional benefit from any of that potassium that was applied. And that's one reason why, I love golf and love golf. I guess I'm probably known more for golf. But the difference that I perceive between golf and I'll lump in athletic turf in there too. The difference I see between golf and athletic turf managers and say sod producers and lawn care operators is that there's in golf and in sport turf, there's a level separated between them and the money, the budget. They're provided a budget. They may go in and defend their budget and argue for more money, but it's not their money. Whereas in sod production and in lawn care, the decision maker, that's real money to them. That's no joke. Okay, so any dollar they spend is a dollar they didn't gain. So they're more sensitive. They're more intimately connected with the revenue and the profit and loss than say golf and athletic turf, because they're given a budget. They're more of an employee in that regard. They're not an owner usually, right? They're not connected as tightly with the revenue and the profitability of the operation as lawn care and sod production. And so the reason I'm saying that is in lawn care and sod production, I don't have any data to support this. This is just all anecdotal. But in lawn care and sod production, I see much less potassium applied than in athletic turf and in golf. I see very high levels of potassium applied relative to the other industries in golf and athletic turf than I do in lawn care and sod production. Okay. And I think a large part of it is due to the connection lawn care operators and sod productions have with the ownership and the money that they spend. It's their money. Okay. I think if there was more of that dynamic infused into athletic turf and golf, we might see some of these wasteful applications of potassium go down. Anyway, I opine. That's all I got for today, guys. We're going to continue with potassium, the beneficial response. Oh, no, it's not what all I got. I'm going to show, hang on. I'm going to go to PowerPoint real quick, and I'm going to put up the scoreboard. So the scoreboard, if you guys haven't seen it yet, the scoreboard looks like this. Let's see if I can get it on the screen. Is it on the screen? No, let me get it on the screen. The scoreboard of potassium is now, looks like this. So we have, I'm going to put the Snyder study here in the positive column and in the none column, because the application of potassium had no, oh no, wait, did it have no effect? No, it always had an effect if some potassium was applied. So I'm going to put it in the positive column. There's not going to be anything in the negative column. They didn't report any negative. I don't think they reported any none except between potassium application rates. So when potassium was applied, it'll go in the positive column. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 potassium papers. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 showing nothing happened out of the 11. I think there's 8 that showed negative impacts out of the 11. And now there'll be 1, 2, 3, 4, 5 showing a positive impact to potassium. 3 of those 5 were on yield. Schmidt actually had a quality, but it was really more survival. No, this is anthracnose. There was quality, and then Snyder had quality. So chalk this down today in the positive column on our scoreboard of potassium. So we're up to 11 papers. 9 show nothing. 8 show a negative response, and 5 or 6 show a positive response. And then there'll be more in the positive column this week. I'm pretty much going over all positive papers showing a beneficial response. But keep in mind that it was on a low case soil, and the benefit came from just a little potassium. It wasn't all this extra potassium, and keep that in mind. I don't know how much wasted money and revenue and time is spent on applying more potassium than you actually need, but it's a lot. You don't need to apply that much potassium in almost every case. Okay. Let me read the chat. There's 1 or 2 questions real quick. So Ignacio says, does the age of the study have any potential difference in the conclusions when compared to newer cultivars? It can. When you say that, there's a couple of new cultivars of St. Augustine grass that I suspect, there's no data on it, but I suspect are going to have a very different nutritional requirement than the older cultivars of St. Augustine grass. And I was doing work on Bermudagrass cultivars in South Florida, and I think we had 1 paper come out from that concluded that the nitrogen requirements was lower between cultivars of Bermudagrass. Now, with potassium, it'll be a long time before we tease out any differences between these cultivars with potassium requirements. But I suspect it's probably very similar to nitrogen. In other words, there can be differences in some of these newer cultivars. Oftentimes, they need less nitrogen. There are some that need more nitrogen, but usually they're older cultivars. The commons, like Celebration or something, might need a little more nitrogen. But some of the newer cultivars, the greener cultivars, at least the data that I've seen, that I've worked on myself, I haven't seen any result in more. They don't need more nutrients. Generally, they require fewer nutrients. Okay, but that'll probably be a while before we tease out any differences on potassium. Sydney Whitaker says, thanks so much for what you do. Looking back on some practices that I used to do, I realized how wasteful was being after learning from your content. I used to dissolve 0062 in my tank in the fall. Yeah, a lot of people used to do that. Yeah, and there may be, like I said, there may be some benefits to applying potassium in the fall on low potassium soils on some turf grasses. So I'm not going to say there's not. In fact, I think there's a paper too on the channel that show there is a benefit, and I may go over that one. That's one of the papers I messed up last year. I'll probably redo that again, maybe this week. There can be some benefit to applying potassium in the fall for when turf grass is going to die from winter kill. You've experienced that in the past because you have low case soils, then there can be some benefit to applying potassium in some situations like that. Okay. That's all I see in the chat. I'm going to let you guys go for now. Tomorrow I'll be back at 10 a.m. Eastern Standard Time. Until then, I hope everybody has a good evening or good day, and I'll see you all tomorrow. Thanks.